Okay, so now we're going to look at the wonders of nature. And when we talk about chemistry, we are actually looking at the, I mean, chemistry is a study of matter, and matter is everywhere, right? Everything is made up of matter. I mean, even outside the earth, you go to the cosmos, that's matter. Now here you see, this is all matter. Water is liquid, the sand is solid, and up the sky, the air is a gaseous part. So three states of matter. Now all these different colors you see, so beautiful colors you see, what is that? That's chemistry happening inside the leaves, right? So this is the chemistry that's occurring inside the leaves. You see this house, you see the light that is coming from the house. Now that itself is also chemistry. Now, this is a painting of Thomas Kincaid. He died, of course, but he's a wonderful painter. He is called the painter of light. You see how he brought this light? The effect of light that he produces in his paintings is also due to chemistry. Okay, certain paints, paints are what? Made up of, either natural dyes or maybe chemical dyes or chemicals, some chemicals, and just their combination and all is producing these wonders. It's amazing. I love his paintings. Look at that. So pretty. So all these colors and all these are all coming through chemistry. I mean, had it not been for chemistry, you wouldn't be, admiring these paintings. So that's one piece. So he was an artist, but look at that. All right. Next is, that's my car. I love Tesla. Okay, so Tesla. Now in Tesla, what do you have? What do you have in Tesla? Do you guys know?
Electronical vehicle.
It's an electronic vehicle, yeah. So it's all battery. Basically, it's a computer. Computer self-drives itself. And then there is a battery, right? And this battery is what? Made up of chemicals, electrochemistry happening right under the battery, right inside the battery, and the car is driving. You charge the battery, the car drives. You don't charge the battery, the car doesn't drive. So that's chemistry. Okay, this is also a part of chemistry, and this is amazing. This is actually the Land's End in San Francisco area. Okay, so here, wait, oh God, it's just so unbelievable. Look at this. These are the rocks, right? And these are the waves. And look at that. These waves, the way they're dashing into these rocks is right in the middle of the ocean. They carved out a heart. So, excuse me. All right. Then is the uh, excuse me. Okay. All right. So now, from time to time, I encourage students to do all these interesting experiments. So generally, students think that chemistry is what? Chemistry is mixing two, three things, and let's see what these guys are up to. They are mixing these chemicals, and students generally think chemistry is all about explosions and chemicals in the lab, but in reality, and see, this is even hot, they're touching it and it's saying that it's hot. It's very interesting. So this is I think it's the elephant toothpaste. They made it in the lab, and it's really funny, but they did this very good lab. So students think that okay, this is all chemistry. No, but chemistry is everywhere. Now let's look at, or students think that this might be chemistry. This is here, another thing, burning things, and like this is magnesium, like giving all this fire and light. That's what students think. But you have chemistry everywhere. Now tell me, what is this here? What is this?
Glass rocks.
Yeah, so these are the glasses which were just the remnants of the trash. So this was a glass beach, and this is in Fort Bragg, which is up north in California. And so this was a dumping ground for trash. So they obviously removed all the trash, but now they have these, they couldn't pick up the glass. So over the time, the waves from the ocean. They came and they kind of like polished the grass, it's an agent of erosion, just like, the waves were the agents of erosion. So what they did was they removed, they took these glass in and then brought them back. So it's kind of like nice and polished. So it has all these beautiful shapes to it, but it's not sharp anymore. But all these colorful glass, now people have, of course, taken away or removed these glass, but some of it might still be there. But it gives a very beautiful appeal to this, this beach. Now, what is glass made up of? What is glass made up of? Do you guys know?
Is
Sand.
and
Sand.
Yes. So glass is basically sand, and sand is silica. So you take sand, you heat it, boil it from solid to liquid, it melts, right? From solid to a liquid state. Now, generally, the liquids, when you cool them, they convert back to a solid, but not the silica. What silica does? Silica is now going to take years and years and years to convert back to, from a liquid state to a solid state. So the problem is that glass is actually not solid. It is actually, it's a liquid, but it is a very slow, slowly it's converting to its solid state. So it's a long processing liquid. So that's what the sand is. And if you go to these, these very beautiful, buildings, then you're going to see that these buildings have the glass, which is thick at the bottom and thin from the top, because like it's liquid, so it's settling down. That's what's happening. Anyways, what do you see is this? What is this happening here?
it's a rocket.
Yeah, it's a rocket. And actually, it's a space probe. It's actually a solar probe, not even a space probe. Now, here's a very interesting thing. Now, sun is extremely hot, like millions and millions and millions of degrees, temperature is very high. So, sun, anything that is going to be in the sun is going to melt. But how could they send a rocket up in the sun to study that area of the sun, or to go closer to the sun? This rocket actually is made up of carbon. So carbon can survive that temperature. So the whole thing is made up of carbon, and then it just goes near the sun. Nothing happens to carbon. And then it just, it's gone there to study the nature of the sun. So we are doing that so that we can produce, like we can mimic the power of the sun on this earth. Now I love this one is very, very interesting. Do you know what this is? Any ideas?
Is it like the gravity, sort of?
Space-time gravity, yeah.
Yeah.
Time. So time, it's very interesting. We think the time to be linear, right? You get up in the morning, you see the evening, and your day looks, it's a linear day. But the truth is, time is circular. That is the reality. Time is circular, it circles, and there's a gravitational pull that affects the time. Now they have done this experiment. They took these two cars, and one was going straight and the other was, bifurcating and going at a tangent. And they wanted to see if the two cars are going to maintain the same speed. But they found that the one that went on a different tangent or whatever, something was changed. They were off. Their speeds were a little bit changed, even though the distance was still the same. So it has something to do with the gravity. Also, the time runs slow in some places, but the time runs fast in some places. We kind of get a feel for it. We get a feel for it. We see that our time is running very fast. Oh, I thought that it was only 10 o'clock. It's 4 o'clock already. Suddenly you feel like, oh, suddenly, where did all this time go? Because time is moving also. And with that said, I mean, we don't know anything about the universe. We really don't know anything about the universe. But they've done all these different experiments there where people who are living on the penthouses versus people who are living on the in the ground floor. And they found that I think the gravity slows down the process. Gravity slows down. So people don't age that much when they are on the first floor versus the people who live in the penthouses because they're further away from the gravity. So the time runs faster for them. So I some thought like that. I don't know, but it's very interesting thought. Okay, you see this? This is the Bose-Einstein condensate. So if you take generally, the matter is three states of matter, right? Solid, liquid, gases. So if you take a solid, you heat it, it becomes a liquid. Liquid, you heat it, it becomes a gas. Gas, you heat it, it becomes plasma, right? It becomes plasma. Now let's look at the cooling process. You take a gas, you cool it, it becomes liquid. Liquid, you cool, it becomes a solid. If you take a solid and you cool it, then this is how it looks. This is absolute zero, near absolute zero. The matter begins to look like the Bose-Einstein condensation. In other words, it loses its identity. So if you really super cooled to absolute, near absolute zero, this is how the matter is going to eventually look. So they've actually done some experiments and found out. Okay. Uh, yeah. Chemistry, there are so many laws in chemistry. So, and sometimes those laws, they are mutually exclusive. So one law is that the total energy of this entire system is conserved. Means, in other words, you cannot change, you cannot like create a new energy from your side. You can convert the energy from one form into another. Okay, you can convert your energy from one form to another, but you cannot, create have you don't have the power to create a new energy, but you can just transform it. It just gets transformed. So in other words, sound energy can be converted to light energy can be converted to heat energy, chemical energy is being converted to mechanical energy. That is why the cars are running. See that? But that's one law. That's the first law of thermodynamics, law of conservation of energy. But then there's a second law of thermodynamics which negates the first law, and that is that the universe is expanding. The entropy entropy is the degree of randomness in the universe is expanding. So this is entropy. This is the second law, which is and then if it's expanding, then where is it getting all that energy from? So we don't have the answer to a lot of questions. One law makes sense to us, but the other law is like totally cancels that first law. So we don't have the answer to a lot of things. And with that said, you know uh Albert Einstein, that's why he said that, religion has to play a role here. And that maybe religion has an answer, that there is some higher power that is controlling everything. We have no answer to it. Till we know it, we just have to believe certain things. So that's what it is. Okay. There's also the random cats of kindness that I have. That's the butterfly effect. Means that every little thing that you do in this world, which is even if it's a little thing, it has a wider impact on this universe. So because everything is connected. Okay. So the butterfly effect is the way they explain it in the theory of chaos is that the butterfly, let us say, the butterfly was in Mexico and it flapped its wings. And then a hurricane struck in China. So that's kind of like a common thing they say. So there is a connection between the butterfly that could sense the change in the weather patterns, and the situation happened in some other part of the world. So everything is connected. That's what the butterfly effect is. So that is why I'm saying, we prepare students for the real world. And in real world, we are actually looking at the problem, solving problems. Hospitals need doctors to solve the problems of, patients. Lawyers solve the problems of, the justice system. Um, Similarly, the teachers, they solve the problems of, educating. You see that? So we are all the time, providing people in the society so some problems could be addressed. So we are trying to make it. So for that said, one of the goal is to make people like a holistic person, those things. Okay, so this is anyways of the, okay, this is also one last piece here. What do you see this? What is this? What is this?
Pollution.
Nope.
It's an aurora, I think it's called.
Northern
Aurora
light.
Borealis.
Aurora.
Yeah.
Aurora borealis. Yeah. So what is happening here is that this is amazing. This is called the neon lights of nature. Neon lights, beautiful. Okay, so what is happening is that the solar, winds have like electrons, and solar winds are striking the Earth's crust and the upper layers of the atmosphere. Obviously there's air, some gases in the upper layers of the atmosphere. So when these winds strike, or when the heat from the sun, when it strikes, and then of course when they strike the atoms, the electrons jump from a lower energy to a higher energy, or from a higher to a lower. And whenever the electrons are jumping, they emit radiations. So this is what that is. Electro. So different colors actually have a meaning, and it also relates to the, I think purple is more famous. Uh, it relates to the color, the gas, I forgot now. Uh, no, where did it go? I forgot actually. It relates to some color of the gas. And where did I put it? Okay, I don't have it written, but anyways, it relates to the color of the gas. Okay, so those things. And what is this you see? What is this?
A nebula.
Say that again.
A nebula, I think.
Yeah, birth of a star. This is the NASA's most iconic picture, pillars of creation. A star is being born. And what kind of chemical reactions are happening? It's the hydrogen. The baby of the universe is responsible for all these beautiful stars. Like hydrogen is nothing. Like it's just the smallest atom in our periodic table. And when they fuse, new things are formed, new stars. So look at that. All these galaxies and all this is all fusion reactions happening in the cosmos. So beautiful. All this is outer planets, see that. So this is the birth of the stars. Okay. Next is, you have any idea what this is? Okay, so these are the the simulations of molecules. So we make these molecules nowadays. Like I told you in my introduction that I worked as a medicinal chemist, but I was working in the lab and making the molecules, multiple step synthesis. But now what they're doing is they say, okay, that costs a lot of money, so now we have these computers, they simulate like as if you have a molecule with a certain kind of structure, and that molecule will have some properties, right? These properties would be like, look at this here. You see this dotted line? This molecule, once it goes into your body where there are the receptor regions, how does it interact with the enzymes or with the proteins in that region? So obviously there has to be some kind of electrostatic attraction, either hydrogen bonding or dipole attraction, or even London dispersion forces. So all these molecules, these are just the shapes of the molecules. These are organic molecules. Okay, so organic compounds, you can show them as line structures. So these organic compounds, they stick to the receptor regions, that is the proteins. And then like GLN is glycine. Okay, similarly, this is adenine. Then this is threonine. So these are the amino acids. And so these amino acids, they bind to these molecules. And these molecules are supposed to produce some, excuse me.
Bless you.
Oh dear. It's just so this is going to produce some kind of therapeutic effect. Therapeutic effect is like if your body is not producing something, then this medicine comes, goes inside the receptor regions and talks to the enzymes like, hey, produce this. Or if your body is overproducing something, and then the medicine goes, sits in the receptor regions and talks to the enzyme, says, hey, you're producing too much, slow down, So this is the work of the drug candidate, basically, the medicine. And so the thing is, when you take the medicine, it needs to stay inside your body. It should, good medicine is something that can be absorbed. It should have a good adment profile. It should be absorbed, it should be distributed, it should be metabolized, it should be excreted, and it should not cause any toxicity. So this is chem informatics. This was a part of my job in my previous, companies. Okay, so oh my God, this is mind blowing. Oh my God, I love this one. Okay, so this is the thing. These are the two magnets. Okay, these magnets have the North Pole and the South Pole, right? You've heard about iron getting attracted to the magnet, but think about oxygen getting attracted to the magnet. Oh God, the same oxygen that you don't breathe. You're breathing, right? You can't see that oxygen, but it gets attracted to magnets. Oxygen gets attracted to magnets. So you take oxygen, you cool it, make it into a liquid. So this is liquid oxygen. And you just pour it down these two poles of the magnet. It gets stuck. It gets stuck here. It's stuck in between the two poles of the magnet. That means it's attracted to these two poles. On the other hand, if you take nitrogen, which is in a liquid form, and you pour it through the plugs of the magnet, it doesn't get stuck. So why? Why is this happening? So for that, the answer to that lies in the molecular orbital theory, So there are lots of theories in chemistry you will be studying, and these theories have the answer to it. And I'll go, okay, yeah, fine, that makes a good sense. So, that's what, this is the wonders of, science. Look at it.
Professor, I have a question about the oxygen or the liquid oxygen. In the last picture, was it frozen because it looked like it?
Yeah, it is. This is frozen right here.
Oh, okay.
Yeah.
Thank you.
Stuck here. So it's frozen because it's attracted to the magnet. Yeah.
Thank you.
Yeah, because it's attracted to the magnet, so it just sticks there. It doesn't fall down, and then it just becomes frozen. Okay. Now comes this piece. This is all chemistry happening in nature. The colors of the fall. I mean, beautiful. You go to like places like Connecticut, South Carolina, North Carolina, Virginia. Oh, so beautiful, so beautiful. Fall is just amazing. It's like, painting. Somebody's just painting. But anyways, here's the thing. Nature likes chaos. This is entropy, example of entropy. Entropy is chaos, that madness, that craziness you see in this. If nobody goes there, and yeah, they don't, there are so many jungles up there, nobody goes there to clean the roads. But that's the beauty is that all these leaves that fall down, eventually, they become humus, or what is it called, the manure for the plants, and then newer species of flowers and plants is born. Nature likes that. That is why nature creates chaos. Nature is responsible for tsunamis. Nature is responsible for earthquake. Nature is responsible for, wildfires. Nature is responsible for hurricanes, because nature, when it creates that chaos, there is opportunity for growth. New and new substances are produced. I mean, if you look at it on this earth, how this earth is slowly evolved. Trust me on this thing, guys. We've made a mess of the environment. So now we have to deal with this pandemic. So we are pretty much confined to the house, because that's what, the higher power or the nature wants us to just get inside everybody, so that the nature can do its own thing. Now, a lot of species of plants and birds that had become actually extinct, you know, But when all the humans are confined in the house, then what do you see? All these newer flowers are being formed, newer species of birds and newer species of, animals, and they've like in 1 year many new species have been reported, so these are the acts of nature that, we keep that in mind, when it comes to entropy. What is this?
Lightning
Yeah. How does it occur?
through heat or warm winds.
Yeah. So the thing is that these clouds, one is positively charged, the other is negatively charged. So these are, obviously come through friction. So they have the charges. And so the moment this positive and negative clouds, they collide, lightning happens. Okay. So this is amazing wonder, again, that's chemistry. Okay. There's so many other things, this is how the liquid nitrogen oxygen looks like. If you take oxygen and you make it, cool it down, it will form a liquid and it's blue colored. Okay. So we can go on and on, this is if you were to do the labs, and this is what these type of labs you would be doing, this is the gases in which we part electrical current, and the electrons, they jump from a lower to a higher energy or higher to a lower energy in the atoms, and they produce lights. And then you look at the spectra. Every atom, this is basically the fingerprint of the atoms, these spectra, right? Okay, so we will talk about these more, but right now I'll just, and look at this one. This is oh God, one girl one time did this presentation on ice, what are these called? Crystals or water crystals. And here's the thing. That's what I'm saying. Everyone is so unique in this one. So there was this guy, uh, I think he was in Europe somewhere, I don't remember, but a place where it was mostly snowing, So all his life, he didn't do anything. All he did was he had a camera and he took pictures of the snowflakes. Pictures of the snowflakes. That's all he did all his life. Then later on, they created a museum. Beautiful snowflakes, millions and millions of them, but not a single one of them is alike. You see that? That is just the biggest wonder of nature, that water, when it freezes, it can create all these beautiful shapes, and then no two shapes are ever going to be alive ever. So that, that is one of the very beautiful wonders of nature. So anyways, we'll talk about this more, guys. There's a lot and I can go on and on, but stop recording.